Hi, if you don't know me, my name's David Kilmer, longtime member of the rock game dev community. I am a programmer by day at a place called Measures for Justice, and I make games as a hobbyist. I have a game on Steam called Reproduction Man. It's a puzzle game. I'm currently working on a puzzle game called Tengam. And I'll actually show you, the reason I'm giving this talk is because when I ended up prototyping Tengam, I did a lot of paper prototyping for it, but I also used p5.js to prototype the game. And it was good enough that I could actually get it kind of play tested by people in p5. So I could get a lot done, a lot of design decisions made before I ever went into a real development environment. Okay, so this is about rapid game prototyping with p5.js. What is rapid prototyping? Oh my God, I used animations. It's a way of testing out game ideas fast, right? If you were at Ro's talk before, he talked about this, so I'm not going to go into it too much. It's a way of finding out how something is going to feel without a big investment of effort. So the whole point of rapid prototyping is you're not polishing anything, you're just trying to find out if something's going to work. A way of trying out different variations of an idea. It's a way of just like it's like a kind of a sandbox of game ideas. And also, I like to think of it as tactile brainstorming. So it's very easy to sit and think with your brain, but very often, I think this is the reason why paper prototyping is so effective, is that getting your hands on something can make you think about a game in a way that you might not have otherwise. So what is p5.js? It's just a JavaScript library. It's for artists and designers. It was basically based on processing.org, if you've heard of that, which is a kind of JVM-based language that's used by media people and artists and to create works of art and interactive displays. It runs in your browser. It's designed to be easy to use and accessible to beginners. And it's like a sketchbook for graphical ideas. So the whole thing is about having a sketch. Okay, so I just want to ask up front, is everybody here program? Anybody doesn't program at all? Okay. All right. So p5.js versus paper. Paper prototypes don't require coding, so that's nice. But paper prototypes often can't operate in real time, right? So there's certain kind of game ideas, and I know in the paper prototype thing, I had one such idea where timing was part of the thing, or the speed at which the thing happened was part of the game, and it was really hard to paper prototype that kind of idea because you just couldn't capture that. You couldn't capture the kind of feel of the speed or the kind of franticness of the play or whatever you were after. Paper prototypes can be super clunky for certain kinds of ideas. It's funny, I was actually kind of walking through like, what would be an easy game to paper prototype? And I thought like Minesweeper, right? Totally easy to paper prototype, right? But then like when I started doing it, I realized like you kind of have to have like a clear table. So, you know what I mean? Like you have to like lay out the cards in such a way that it actually all logically makes sense, right? So if you have a bomb in the middle, you have to like have all the flags, the numbers around it be the right number. So like for each board that you make, you have to do all this work just to like lay out the board to be consistent. Whereas a computer program can do that in moments. So even games that might seem to be, if you're getting into starting to do a paper prototype and you're like, oh, wait, maybe this is too much, this might be a good approach. In general, I would say if paper is good enough, use paper. Because the whole point of prototyping is not to like invest a bunch of time and effort. And programming is time and effort a lot of time. So why not just use Unity? Unity has a drag and drop designer. p5.js is all in code. Like there's no graphical tools or drag and drop or buttons or anything like that lets you do it quicker. So why not use Unity? I would argue that like in Unity, if you're really trying to do something non-trivial, even in a prototype, very often you're going to have to write code anyway. If you're already good at Unity, and that's already super fast for you, Unity's probably going to be a good tool. But there's also rabbit holes of Unity, and I found myself falling into them. I started doing a prototype in Unity, and then I all of a sudden found myself like 3 hours later, and I'm writing a shader. And I'm like, well, that wasn't what I intended to do, right? Like I start to concern myself with how things look, what the presentation is, and I wanted to use an environment that takes all that away. So it avoids those kind of rabbit holes. Using P5 means that if you do it in Unity later, that means you have to start all over from scratch. Some people would consider that a bug. I would consider that a feature. I think the idea of a prototype is you really want to be able to throw it away and start over. And if you get to the point where you've got enough code structure where you're like, you start to feel weird about throwing it away, you've probably written too much code in your prototype, and you should, try to shoot for something smaller. This is just my opinions, by the way. I'm not an expert. If you absolutely need 3D, also, I think P5 is not a good tool. It does have 3D tools, and they can be worth learning. They use WebGL, I believe. But I think it's a little involved for prototyping stuff. So this is all going to be 2D, what I show you tonight. Okay, so I want to talk another thing about, maybe this doesn't apply to any of you, but it applies to a lot of people who are doing prototyping work and are writing games, is the idea of coding anxiety. So coding often has a high barrier to entry. People think of people who know how to code as being experts or magical in some way. That you have to know a lot to get started coding. Code is very abstract. You have to be able to think in abstractions in order to code that don't map to real-world things. There's a lot of things in like object-oriented programming that try to get around that, but very often it requires a lot of abstract thinking. Also, coders are often portrayed as being magic. Like I always love that. There was a movie, I think it was one of those adventure movies where they're driving down the street and there's a guy on a laptop like hacking the traffic lights as they go down the street. And it's like, yeah, okay. That's the kind of way that they're portrayed, and I think that causes people to be a little intimidated by it, like it's magic or something, which it's not. And a lot of people say, I'm just not good at coding. The truth is, games are really systems of rules. And so you're a game designer, you want to design a game. A game is a system of rules. Programming is a system of rules. I think very often code is much more like game design than what people think, or that the code that you write to express what your game does is much more related to the design of that game than you might think. So it's a good thing to know. It's a good way to think if you're thinking about designing systems. Libraries like p5.js significantly lower the barriers to entry, which you'll see. Concepts, I think, are metaphors. So once you find the right metaphor, it will click. So just keep looking for information. If you're running up against a wall trying to learn something like P5, just keep looking up some things until you find something that clicks. Because really concepts are just, you'll find something that's like, it's like this. A dictionary is like this. A map is like that. And it will click eventually. And also, like, something I think is really super, super, super important is that, especially when you're prototyping, writing good code has zero importance. Whether you're going to see bad code here today, and I'm proud of that, because it really doesn't matter. What you're trying to do is prototype a game. The code and how good it is and how it's structured and whether it's a function or whether you split things out or use a switch statement or whatever does not matter, period. So keep that in mind, and I think that reduces the anxiety for me, especially going into game programming, where I was like, I don't really know what I'm doing. And when I finally let go of that and I said, I'm just going to try to make something show up on the screen, it got a lot more fun. Okay, so here's what I'm going to try to do is just focus on the P5, not on the prototyping so much, because it's like, I'm trying to do this within like another 40 minutes. So, but we do want to try to design a very simple interaction using P5. And you will be able to do this, so we're going to be able to do it over the web. So if you try to hook up to the internet here, I do have a USB drive if you can't. There's an online editor. It's at https://editor.p5js.org. If you just go to p5js.org and go to download, they have a link to the editor, which I'll show you. Right, I already said that. And then my wife said, you have to have pictures in your presentations. And I didn't have any at all. So that's my cat. We call her Kitten. She's a happy cat. Okay. All right, so I'm just going to go to p5.js. I'm going to see if I can maximize this. So what I usually do is a p5.js, there's a couple ways to do this, and I'm just going to go over both of them really quick. Here there's a reference. I always have this reference open. This tells you, this is like one page, right? I'm scrolling down. There seem to be a lot of functions, but like I go on this page and I'm like, I want to know how to draw a rectangle. Search rectangle. Okay, there's a rectangle function. I click on it. That's how I do it. It's got examples. So this is how you interact with this language. For the most part, you've got this screen open all the time. Sorry about that microphone thing. Okay, so also, as they say on the download page, they have this thing called a web editor. This is in beta, I think. It's not perfect. It has problems. But this is a really good way to just do things really quick without having to set it up on your local drive. So I can just open up my code. It saves all my code here. You can set up an account. If you don't set up an account, you can't really save things. You can like delete things or whatever. If I want to delete this, I can do so, and you can pull up a bunch of code. In addition to the code that you save that's yours, you can also just go to the examples. In the examples, they have a whole bunch of things. So for example, like here's a flocking library, and if I'm just playing it. So this does something, and I think it's using the Boyd's algorithm, which is a cool algorithm that's worth looking at. So if you just pull up examples, you can start to see how to do things pretty quickly. I didn't write this example. Okay, here's the way that I do it on my machine, and I just want to show it to you real quick because sometimes going onto a web browser is not the most productive way for a lot of people. So I'm just going to show you how I do it on my machine really quick. Basically what I do is I have a directory on my machine that holds my code. And I have a repository up on GitHub that you can look at if you go to github.com/dkilmer. You can see I have this p5 proto. If you pull this repo, you can see how I do it. So basically I have this structure that's got the p5.js libraries in it, and then it's got a bunch of folders, and I have an empty example folder which my new examples get created from. I wrote a couple scripts like new project, which basically copies all the things from empty example to a new folder and starts me a new project. What I do then is when I go onto this, I wrote a little script called run server. So since it's JavaScript, it's kind of, you have to run a little local web server. I know that in Windows, this is kind of a pain in the butt. On Mac, you've got Python already on here, so it just runs the Python web server. On Windows, I would download a thing called Mongoose. I have it on a drive here if you want it. It's just a little web server that'll run in the current directory and serve out index.html from the current directory. What's going to happen when I run this server is it's just going to run on port 8000. And if I pull that up, what you can see is if I go to localhost, it just shows me the folders. So if I click on one of the folders, it just runs that code. And if I want to, I can run my web console. And so that should, I can't, for some reason, there we go. See if this works. I should be able to kind of mount this to my window, but I'm having trouble with that. So you can see like it's logging the things for my app. The left mouse button was clicked, blah, 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 right? Okay. So that's basically how I do it. Tonight I'm just going to go into the web editor to make it easier to look at. If you're interested in running the code that way, just go to this repo. It's I'll post it in the Discord afterwards. It's github.com/dkilmer and then the p5 proto thing. If you pull that, I even created a batch file to create new projects and stuff. It should work under Windows. Okay, so I'm just going to go back to the editor now and start walking through some stuff so that you can see how p5.js works. Okay, so I just say file open, and I'm going to start at the beginning here. Okay, so this is what p5.js is. Essentially, there's a setup function, there's a draw function, and then there's functions that are events. So the setup function gets called automatically, and it should create your window. You use a function called create canvas, and you have a width and height for that canvas. Then there's a draw function. It's called a lot of times a second, optimally 60 times. that's not guaranteed. This is JavaScript world. It usually gets called 60 times a second. And then I have a mouse clicked and key typed thing. So there's also a little console here, so you don't have to have your web console open. So if I hit run on this script, it doesn't do anything except print something when I clicked it. And you can see things already that are happening. So if I click up here in the left-hand corner, you can see that where it clicked was 1010. And if I click down here, where it clicks is like 386, 383. That means that the way that the coordinate system works in P5 is upper left corner is 0, 0, down to the lower right. It's similar to the way Windows draw APIs have worked from time immemorial, but different than a lot of other systems. So, and then we also have a key typed. If I type a key, it'll say the key G was typed. You can see there's all these global variables like the key. It doesn't get passed into the function. It's just there for you. The mouse button also is a global variable. The mouse X and mouse Y are global variables. You can access those in other functions if you want to know where the mouse happens to be at any given moment. There are other functions around how the keys work. So if I go back to my reference and I look at key, I can see there's key typed, key pressed, and key released, which is when a key goes down and when a key comes back up, which is different than typed, which is when it is both pressed and released. And then key is down, which just tests at any time whether a key is down. So those are the functions around like getting input. Similarly with the mouse stuff, you have mouse moved, mouse dragged, which is when the left button's down and the mouse moves. Mouse is pressed, mouse is released, mouse clicked, and mouse double clicked. You can get the location from any of those things. So if you want to respond to those events, it's super fast to just throw a function up and respond to it, as you'll see. Okay. Am I going slow enough? Okay. So I'm just going to look at basic things. I think you guys pretty much probably know all this stuff, so I'm not going to go into details. But basically, one of the things about JavaScript is that you can have kinds of variables that aren't just integers and strings. You can have arrays, which are specified in brackets, and you can have these things called objects, which are basically look like little pieces of JSON where you have a dictionary of a key and a value. So here I have name, me, age, 38, tall, true, all of which are true. And so those are treated just like anything else. You can pass them into functions and do things with them, and you're going to see me do that. So right now, you can see I run this function when I start up and just create a canvas, and I'm not doing anything additional than I was doing before. If you are new to coding, what I would recommend is have these functions. At the bottom of your code, I have this do-if function, and I have like all these little things like an if statement, and I have a do for loop function. The reason those exist is not for me to call them, but for me to cut and paste from them. So if I do things that are pretty common in prototyping, I start copying those into my example thing that I copy from. So then when I start a new file, I just cut and paste the whole file in. And now I've got all these things that I can just copy and paste. So you can see here, like, obviously I know how to do a for loop. I've been programming for a while. But here's one that walks through y and then x. And I use that constantly. So instead of typing it up every time, just have it there in the code and pop it in. So that's a good way to do it. All right, so I'm going to go to the third one where we're going to actually draw some stuff. Okay, here's something different. I call it a function called random seed at the top. The reason I did this is because I'm going to use a random number generator in the program. I would recommend, if you're going to use random number generators in your program, always call random seed and always just put in some number in there. Reason is, your program, if it does random things, it will do the same random things every time, which is really useful. And you can call that number. So if you'll see, like, if I run this program, which I'm going to do right now, what it's doing is just printing random shapes on the screen, right? And it's actually doing, if I run this again, it's going to print the exact same sequence of things in the exact same order. That can be useful when you're writing a prototype. If you're trying to figure out what's going wrong and you're doing randomness in your game, you'll want that. So that just seeds it off. I just put a random number in there. There's a number that I actually personally use all the time, but I'm not going to tell you what it is. Okay, so in the draw function, what it did was it draws a background. You can do a red, green, blue. So if I wanted to do 0, 0 here, that would work, right? Now it's red. If I change it to make this 0, now it's going to be green, right? So that's just a number between 0 and 255. If you just have one number, it's a grayscale. So these are the kind of nice things that they do. In my prototypes, everything is grayscale because that just makes it like I'm not wasting my time thinking about colors. Don't think about colors. So then when I draw, I'm calling this, so what does background do? It basically clears the screen. So what if I just comment this out? Say I just don't do that. What's going to happen? It's not going to clear the screen. It's going to draw a random thing every frame, and it's just not going to clear it. So that's kind of cool. So what does draw a random thing do? This is just a way of kind of walking you through the things. So I call this function called set random fill and stroke. So when you draw any shape in P5, there's these things called fill, stroke, and I'm also calling a thing called stroke weight. So fill is just when you draw a shape, what color is it filled with? When you say stroke, it's like what color is the line that I'm drawing around it, and stroke weight is how thick is that line. So I'm randomly selecting numbers. You can say I use the floor function because I want an integer. You'll see this pattern a lot using floor because when you call random, it gives you a floating point number, and I actually want an integer. So I just call floor. You'll see that constantly. I probably should just have a shortcut for it. But this basically says choose a number between 10 and 256 for the fill color, choose a number between 10 and 256 for the stroke color, and then give me a stroke size between 1 and 4 pixels. And then I set those. And so anytime you set those, they're now the effective fill and stroke. So anytime you draw a shape, if you draw 3, they're all going to have the same type. So anytime you call these again, it changes it. So it's kind of like OpenGL in that way, that it's kind of got a current state that it's in. And that can be really useful. It can also create a lot of bugs. So very often I'll have a function that just sets those at the beginning of anything I want to do. I also think it's a really good idea when you're prototyping. I have this function called draw a random circle, which just picks a random x, y, and radius, and then draws an ellipse with ellipses actually have width and height, and I'm using the same, which makes it a circle. There is actually a circle function, but there's a problem with this editor that's not working properly, so I just used an ellipse. Very often what I'll do is I'll have a little thing, a function like this, that's like draw my player, and it'll say draw a circle with this fill and this thing, this stroke, this fill, and maybe even do an animation or whatever I want to do, and I'll just keep that in a function and I'll keep that around. That way, anytime I want to draw the player, I might just say draw the player at this location, and it'll just draw it. So I really recommend just having little functions that just do little pieces of drawing. In this case, I'm doing a circle, which is just ellipse, an ellipse, which is an ellipse. Draw a rectangle, which is x, y, width, and height. Text, which is text, a string, and an x and y at which to draw it. There's additional functions about how that string is aligned. I try to ignore those as much as possible, but very often I want to center things, so there's a text aligned thing that you can look up in the thing. So that's it. And basically, so what I do here is I say set a random fill and stroke, then pick a random thing. It's going to be from 0 to 4. You can see I choose random 5. That means it's going to be 0 up to and not including 5. If the thing is 0, I draw a random line, 1, 2, 3, or 4. I could have used a case statement here, but I didn't. Why? Because if I want to add a different thing, it's a little easier for me. I don't have to worry about drop through, whatever, right? So a lot of times, like, use if statements. Don't try to be fancy. I didn't do anything different. It's just more likely. It's not more likely to do anything. It's more likely to draw text. All right. So I'm going to open a different example. I was on 3, so now I'm on 4. So this is about clicking things. So what I want to do here is I'm doing the same thing. Now I'm creating a variable for my screen size. And I'll show you why I always do this at the top. This is going to be a grid-based thing. I should actually just run it so you can see. It's going to draw a grid. And I want my grid size to be 10 pixels. So now, like if I wanted to, the reason I have variables at the top to calculate these things, that means that TW means that my tile width is my screen width divided by my grid width. So that means that I want to know I have 600 across, I want 10 of them. So how wide are they going to be? 600 divided by 10. So what's cool about doing it this way and setting your stuff up this way is because if I want to make it 400, I'm still going to get 10, but it's a smaller screen, right? If I want to go back to 600, but I want to do 20 of them, I can do that really quick. I can do 20 and 10. It still works, right? So that's a great way to kind of start out if you don't know how big your game's going to be or whatever at the beginning. That's how you do it. And then I call this function called makeGridArray, and I want to do the width and the height of the thing. So I want a 10 by 10. And why am I making a grid array? It's because the state of my game is going to be stored in some array, and the actual stuff on the screen is just what I'm drawing. So I think keeping those two things separate is a great thing to do. So let me look at the create grid array function. This is a little bit weird because in JavaScript you've got an array of arrays to have a two-dimensional array, but it's a really nice way to refer to it. So I want to say like grid x, y in square brackets. And that makes it nice. So I have this function. Some people are a little confused by this stuff. There's other ways to do this, and if you look it up on Stack Overflow, you'll find at least 25 different ways to do this. So basically what I'm doing is I'm just creating a new array. Fine. Now I've got an array that has a set of cells for all my x cells and all my y cells. Then when I call setup, I actually want to walk through that grid, and then I want to set the value at that to a number, and I'm going to set it to 0. Then when I draw, I'm going to draw a rectangle at that gx, gy location. What that does is it gets the x, which is whatever my grid x is, times how wide my tiles are, and then it draws a rectangle at the tile width and tile height. So that's just a quick way to draw everything. That's my whole, each square is being drawn separately every frame. Okay, great. So now I have a mouse click and I want to find out which of these tiles got clicked. How do I do that? Well, my mouse click tells me the x and y of the screen position. So in this case, this would be around 580, 580 or whatever. But it's 9, 9 on the grid. So let me actually change this real quick so you can see both. So the mouse was clicked at 572, 566, but that's at grid 9, 9. So 0, 1, 2, 3 through 9. So all I'm doing is I'm dividing where the mouse is divided by the tile width. If you're prototyping, one of the things that you might want to do is like, this is ugly, right? I want to create a nice little margin around it. Now you've got all this other calculation that you've got to do to like make sure. Now you got to add on your margin and then subtract off other things to figure out where your mouse is. This is super easy. I look at the mouse width, I divide it by my tile width, now I have what grid width I'm in. The reason I use floor is, again, that's a floating point number. So I would get 0.0, 0.1, 0.2, the whole way up to here where I get 0.9, and that all floors to 0. So it's 0 the whole way up through the very end. Okay, so when I click it, what happens? I set the value to 1 at that grid. So all I'm doing is changing my abstract structure and changing the value to 1. When I draw it, I look to see if it's 0. If it's 0, I fill with 200. If it's 1, otherwise I fill it with 100. So all these ones are getting set to 1, right? So that's the beginning of a game already, you could see. And this is just a couple lines of code that I added. What I could do is make my mouse click function, I'm setting it to 1. I could basically say something to the effect of, if it's equal to 0, then set it to 1. Otherwise, whoops, I can't type. Otherwise, set it to 0, right? So this is just a quick way. So now I'm implementing something that just else 0. Whoops, that doesn't work. Automatic indent doesn't work. Okay, so if I run this, now what will happen? I change it to 1, right? I'm clicking on them, and then I click them again, and they're off again. Right? So that was just a one-line change, and I have like now a little bit of logic in my program. All right. I'll save that. Let's look at the next one is 5. So this is like timing issues. So now what I did was, if I click on this, I want to make something change over time. So how do I do that? So I'm going to do something different. Instead of just putting a number in the grid, I'm going to set that place in the grid to a color. And so I'm setting an object into the grid instead of just an integer. The reason that is, I use this pattern constantly because now I can do anything in that thing, in this thing. I have that thing called color and it's set to 200, right? But I could add anything else I wanted. I could add like cats, 3 or whatever. It doesn't matter. So now I can just like add information to my game without changing any of the graphics or anything else. I'm just like setting up an object that I can do things with. And I'll show you how that works. So when I draw, I basically pull that color off the grid. So I can pull that off the object by saying grid gx gy .color. And I can access cats the same way. Anything that's in that object. If it's not in that object, JavaScript is fine with it. It's just undefined. And it may give an error, it may not, depending if you're trying to add something to undefined, it might give an error. So what am I doing when I draw? I'm walking through all the colors and I'm adding 2 to the colors while they're less than 200. So on every frame that I'm drawing, I'm looking at the color that's at that point in the grid, and if it's less than 200, I'm adding 2 to it, right? That's all I'm doing every time I draw. When I click on it, I look to see what I clicked, just like the last example, and then I set the color to 0. So the color starts out at 200. When I click on it, it changes to 0. And then on every draw update, it looks to see if it's less than 200, and if so, it adds 2 to it, right? So that's basically what's happening. I click on it, it goes to 0, and then it slowly fades up. I'm not trying to time anything. It could happen within a second or whatever. But if I feel like this is too slow, all I have to do is say color equal color plus 4 or whatever. Now it's going faster, right? So that's a simple way to do it, and I'll show you in a second. So 2 things with that example. Basically, I've got a grid-based game, and I'm storing an object at every point in the grid, and now I can track what's happening in that whole grid, what color is everywhere all at once. And I can draw the whole thing every frame, and it's fine. All right. So now we're going to the last one. Oops. How am I doing? Great. All right, so this one is going to try to do something different and try to move an object around on the screen, right? So I had to click over here because it won't take my keystrokes unless I'm actually on here. So basically what I want to do is walk this guy around. So what you can see is I draw this little guy. So on every frame, where's my draw function? Always put your draw function near the top so you can see what's going on. But like I draw the player every frame, and I draw every grid rectangle every frame. So the grid rectangles work the same way as last time. They get lighter up until they hit 200. And then I draw the player. The draw player function is just look at where the player's position is, which I'm storing as a global variable, pgx and pgy. And then I am translating that into a screen position. You can see something weird here. Since I'm drawing a circle, the center of it is not the upper left corner of it. It's the center of the circle. So you can see what I'm doing here is I'm adding, where is it? Here, draw player. You can see I'm taking the grid, I'm taking the position, the grid position times the tile width to get how far out to put them. And then I'm adding the tile width divided by 2 to get me to the middle of the tile, right? And then I draw a circle there. And you see I'm subtracting 4 here. And the reason is because I didn't like it if he took up the whole, if my little player took up the whole space, right? That didn't look cool to me. So I just subtracted a little bit. This is the kind of thing you do when you're prototyping. But let's say that I wanted to give him a little bit of motion. What would be easy to do is just to set up a timing variable. So let's say I say time equals 0.0, right? That's my time. Every draw function, I'm just going to add, I'm going to say time equal time plus 0.1, okay? And then I'll just like make it go around in a loop. Let's say if time is greater than pi, time equals 0, right? So now time is going to count from 0 to pi by 0.1. Every time that it draws, it's going to add 0.1 to time. So I'm no like fancy timer. I'm just adding 0.1. So now let's say I wanted to just say that his width, that this player's width is going to actually be, so we'll say like var r equals time times tw divided by 2, right? And then we'll just make it r here, right? So now I'm going to change his size based on the time. Well, he got a little bit too big, right? Because time is pi. So let's just do a sine on that. So I'll do a cosine. Cosine starts at 0. I like it better. Team cosine. Now it's tiny. So things like this will happen to you, right? So I can say times pi. I don't know. Not big enough. Whatever. Right? Oh, I forgot my times. Yeah. What I meant to do is this. Cosine of time. There. Then we'll change it to r. There. There you go. So now you can see he kind of goes back and forth. And that's useful, like to get a little bit of motion into your game. That can be useful. So now I'm just like, as a final thing, I just want to show you like, this is the kind of thing, this took me approximately like maybe a half an hour to do. Let me save that. Here's something that took me about a half an hour to do. It's Minesweeper. Okay, so it's all the same things, right? Like I have this tile, and instead of having just colors or whatever, I've got up, flag, bomb, or bomb count. So that just stores what's in that. So that's what would be on my cards that are on the table. I generate those randomly. I have a function that, so now since I use a seed here, that means that every time I generate a board, it's the same board, which is really useful for this prototype, right? So basically, I generate this board at the beginning. Where am I doing it? Random seed. Create canvas. Text size, text line, new game. So I must have a function called new game. Where are you? There it is. So for the new game, all I'm doing is just changing what the tiles have in them. And then I'm calculating what the bombs are. And that all takes like, a couple seconds. So basically you can see how ugly my code is here. If it has a bomb to the left of it, then, whatever. So it's like looking around a space and saying, how many bombs do I have around me? And then it's putting that number into that space, right? So that's how you basically create Minesweeper. And you can see, like, I didn't bother doing lose conditions or win conditions. I made the game work. But I didn't, if I click on a bomb, geez, I usually click on a bomb within the first 2 seconds. There. It doesn't say I lost. I can just keep going. If I wanted to do that, I could, but I'm rapid prototyping, so I don't care. I just want to see how it feels. So if I was doing some kind of, change to Minesweeper, that's what I do. I'll show you one more thing that I did. This is a game. This is the prototype that I did of Tengam in P5. So all I did was, you can see I did it all in grayscale. I did do movement. You can see I actually did a little lerping on the movement because I wanted to get a feel for what it would feel like. But that's it. So, and that actually took me like a day to prototype at the most. All right. I think that's it. What I wanted to do is see if what we could do is pull up the editor and try to do something real fast. I don't know if that's worth doing or if we have enough time to do that. You think so? All right, let's do it.
So does p5.js give you a way to kind of package this up and publish this at your website, or?
No, they have a way of putting it. In this editor, but to back it up on your website, like if I just took the thing, like what I did to get this guy, is I essentially took that directory that I showed you at the beginning and just SSH'd it up to a web server. So it's all there.
Include like the p5.js library and then your code.
Yeah.
That reads into this.
I'll actually show you that real quick, just so you can see. Huh? Oh, I am? Oh, that's awesome. So we can actually code some stuff. Awesome. All right, so I'll show you this real quick just because you asked. So if I look at my example, let's just look at the last one. There's an index and a sketch. So here's what the index looks like. It's just this. And you can see it's including it out of ... but you would just change that to be in wherever it was relative on your web server. So that's it. And it's just loading sketch.js. And then sketch.js is the same thing I showed you. So that's kind of nice. And I don't know, like it was something that I was thinking about for the MFJ work a little bit because you can do animations really fast and draw shapes and do stuff like that. That was the original reason I started looking at it. I don't think it plays really well with React though. So that's an issue. All right. So the idea of the workshop was to try to code an interaction. So if you have a computer in front of you and you can go to the editor, I think what would be fun is to try to do something from scratch and see what you do. So I'm going to get Ro to help me. Okay. So you just saw what P5 can do, right? So what we want to do is do a prototype of an idea that you could do a prototype of in, maybe a half an hour or something like that. Using this, like something, maybe it is a paper thing. Like I'm not going to get picky for this workshop, but like, what would be an idea? I think Minesweeper is like a little on the too complex side. But I could do like tic-tac-toe. Tetris would be complicated. What did you say?
Pitfall.
What's pitfall?
Where you're falling down a pit and it's just like the walls change and you have to like avoid the wall.
Pigpen, or what it's called, Pigpen game where you draw an idea dots, and you play it in that usually you draw them all, and you try to color the pens.
Oh, that's a good one.
Yeah.
Let's try it.
Can you repeat that for the screen?
Yeah, so you called it Pigpen?
There's another name for it that's more common.
Basically, it's a game that you draw dots on, you have a grid of dots, and then the players take turns drawing a line between the dots. And then you win by, you close one off, you get it. Okay. That's awesome. That feels like something we could do pretty fast. And in fact, like so I think this is good for a workshop. I think it's good to try to do as an exercise. So let's try it. Something similar at least. So basically the idea is, the idea here is, the case that I'm making to you is that this is a good tool to rapid prototype in. And so generally that becomes the case more and more the more code that you have, right? I just copied Minesweeper, which is a really bad idea. Okay. Let's copy a simple example like this one. Actually, you know what I'm going to do is I'm going to start from scratch. Okay. So if you were going to start doing this, the thing that I would do first is I always do the screen width and screen height thing, right? And then I do my grid however big I want my grid to be. So like what if we made it 10 by 10? That would be fine. You know.
You wanted to do something a little more visual or more movement oriented. I'm going to make simple space invaders.
Like Space Invaders?
Yeah, because if you just could scope it down to a moving thing coming towards you, and hit the bottom.
Yeah. Yeah, I think we should try to do it. Like, how should we do this part of it? Can we just do it as a kind of like, I don't know if it makes sense for me to kind of stand up here and code it, or if I can kind of like. Do you have a computer with you? You don't. Yeah. Just people in general. Some people have computers and some people don't. So I don't know if it's worth like me sitting up here and coding something, or if you want to. Huh? Okay, let's do it that way then. All right. So which idea should I take? I think it might be fun to kind of do a Space Invaders style thing, just because I showed you like kind of grid-based thing, and it might be cool to see something that's not grid-based. So let's just say that we have a screen that's 400. We're going to create a canvas of that width and that height. And when we draw a background at 220, boom, it already works. Let's make it bigger because it's too small. Fine. Now we got a screen, right? So what do we want next? We want a player, right? I think that's a good thing to have, right? So let's put a player on the screen. We'll call it px and py. I'm just going to put 0. And then we're going to draw a function to draw a player. So that's pretty easy, right? Function, draw a player. And then we're going to draw him. Let's make that a rectangle, right? So we'll just say, I'll say fill 200, stroke 0, rectangle, px, py. And then we'll have like, we'll make him like 40 by 20. Let's see what that looks like. I don't see him. Why not? Because I didn't draw him. Draw player. Fine. Now we're drawing the player. There he is. He's too small. We'll make him 100 by 50. Awesome. There he is. He's big enough to get hit now. But he's at the top of the screen. Where should we put him? He's 50 tall. We have 600, so it should be 550, right? So we're going to make him at 550. We're not going to let him move along the... Oops. Somebody saw that. So we'll put him halfway across the screen, which is like 300 minus his width, which is... oh, I'm doing a terrible job here. I did 150, right? That's his width and height. Okay. His x is going to be halfway minus his width, which is going to be like 300 minus 50, which is 250. And then his y is going to be 600 minus his height, which is 50. So that's 550. So what does he look like now? I stopped drawing him. This is what happens when you undo. All right, great. We're drawing him. There he is. He's at the bottom of the screen. He's in the middle. That's where he starts. Now we want to move him, right? I forget how to move him. I want to use key down key down instead of key pressed, right? Because I don't want to make him move by like pressing a key, pressing a key, pressing a key. So let's just say mouse down. Mouse?
Key down, right?
Yep, you're right. Key down, sorry. Jeez. Did you see it? 0, 0. Key is down. Key pressed. Key pressed. There it is. So we say function key pressed. And then I'll say, I wonder how I could do arrows. Arrows would be better than WASI, right? Yeah, everybody likes arrows better. I don't know how to get like up or down. But it does say here, arrow down. It says for non-ASCII keys, use the key code variable. It says up arrow, down arrow, left arrow, right arrow. So I'm just going to use left arrow and right arrow. I'll say if key code equals left arrow, good. Else if key code equals right arrow, that. So what we're going to do, we're going to jump him a little bit, right? We'll say px plus equals, I don't know, 4. And if it's, oops, we should probably say minus, huh? And then if I use the right arrow, I'm going to say is plus. Fine. Now I should be able to move him around. He's going to move automatically because we're already drawing him at his position, right? I got to click on this. Oh, I used key pressed. So that only happens when the key is pressed. So now I just want to have a variable, var L down equal false, var R down equals false, right? So I did it wrong, basically. I want to say L down equal true, and R down equal true. And then I just have a key up function, which is the same thing. I think it's called key released. Once you get used to these things, it's a lot faster. So basically, I just want to grab these. Right, and I'm just changing these to false. Fine. So now so I want him to move while that key gets held down, right? So I can say, I usually would just create a function here and just say function move player. Fine. So I'll say if L down if L down px minus equals 4, else if R down px plus equal 4. Fine. So now when I run it, it should work.
Yeah, you didn't call move player anyway.
Thank you.
You missed a semicolon after that move argument.
Where? After what? Oh.
After PX.
You know why? Because I code in Kotlin all day. There we go. So now we have kind of a bit of a problem, right? Because you could just move off the screen if you want to. Right? We know his position, so we basically say if px is less than 0, px is equal to 0. And we would say if px is greater than whatever his width is, 600, 500. It's probably bad to put 500 here. I should probably say like screen width minus player width or something like that. Right? Px equal screen width minus player width. So that's a better way to do it. Like if we do like var pw equals 100, var ph equal 50. Jesus. All right, so that's that. So I'm just going to use player width and player height here. That makes it a little better just to be able to see. There, now he just stops on either end, right? Fine. Everything's fine now. All right, so what do we want to do next? Make something come out on the screen, I guess. Oh, we got to shoot. All right, so let's shoot. So if you shoot, should it just repeatedly shoot? We could test it. Let's just do key typed. Wait, what's that? Yeah, that's what I'm going to do. If key equals, I think I can just do this. Then we'll say fire. Right now I'm just going to see if this works, because I don't know if it will. Fine, it works. So now we just need a function to fire. Okay, so this is fun. When we fire, what do we want to do? We want to create a bullet, right? Can there be more than bullet at one time? Probably. So let's just create an array of bullets. We'll say var bullets equals a blank array. This is where JavaScript becomes really great. So basically what's going to happen is every time he fires, I'm going to create a bullet, right? So when I fire, I'll say spawn bullet. Right? All I'm going to do is I'm going to create a bullet, and I'm going to push it onto that array of bullets. So I'm going to say bullets. This is just JavaScript. This isn't P5. So I'm going to push a new bullet onto the array, right? That bullet is going to have an X and a Y, right? The X is going to be whatever the player's X plus PX plus PW divided by 2, right? And his Y is going to be PY is probably fine. And that's it. I think we just need that. So we kind of put it at a center position of wherever the player is and at his top. And so we just pushed a bullet into the bullet array. So now when we draw, we want to draw our bullets, right? So let's have a draw bullets function. And then I'll just say, I'm doing this the ugliest way possible. For var I equals 0, I is less than bullets dot length, I plus plus. And I'm going to say, I'll say fill 100 stroke 0. And then I'm going to say circle. I'm going to say var b equal bullets sub I. Right, so now I've got a bullet, and I'm going to draw it at b.x, b.y, and I'm just going to make it like 40. I don't know what it should be. Right? I don't see it drawing the bullets. Why? Because I didn't call draw bullets. Mm-hmm. Didn't I? Oh, yeah, I got to call spawn bullet too. Spawn bullet. Awesome. This is why I should code like this all day. I should just have people watching me code and just telling me all the mistakes I'm making, like live as I'm making them. That'd be awesome. There it is. We have a bullet. It's way too big. So I'm going to make it a little bit. Actually, you know what? I'm going to create a variable. I do this all the time. We'll just call it bullet radius, right? And I'm going to set it to be 20 because 40 was too big, right? So where did we spawn the bullet? We're going to spawn a bullet, and we're going to say, we're just an X and a Y. So when we draw the bullet, we're going to draw it at bullet width. Okay, does that work? Damn it. It's a radius, not a width. Okay, it's great. Okay, so now all we want to do is every time that it updates, we want the bullets to go to the top of the screen, right? That should be easy enough, right? We're going to actually cut and paste the code that we wrote here. You can see we actually created a bullet. So we're just going to say function move bullets. Okay? And then we're going to say b.y minus equals 8. Random number. Oh, you do have to call your functions. So basically this is moving any bullets that exist, it's going to keep moving them up. So let's see what happens. We're also going to move the player, and we're going to, I called it move bullets, right? Yeah. Move bullets. Great. Let's do it. Whee! Look at that. So that was like what? Like 6 or 7 minutes, right? Now, obviously in Unity, you might have been able to do this kind of thing just as quickly. But again, it's based on the thing that you're trying to do. And very often, this is a great way to kind of just get something down and see whether you like it. The problem is, right now, my bullets array is getting very large, and the bullets that are going up are just continually going up till the end of time. So probably I want to yank those off the array when they hit the top. And so I'd probably ask Andrew how to do that. So let's say that we draw the bullets. When we move the bullets, we'll say if b dot y is less than 0, what?
Array, what's it, unshift, we'll remove something out of it.
Yeah, we'll say bullets dot unshift. And I can do it at I, right? Or is it bad to do that while I'm iterating through the array? Huh? Say it louder. Yeah. You could, and I could also just create a list of the indexes that I want to delete, right? Or something. But we're going to find out what happens just for fun. Very often, I'll do something like this in a prototype, and it'll behave in a way that I didn't expect, but that is interesting. And that is kind of like one of the hearts of game design. What actually happened was it threw an error. So big surprise there. I can never remember the keystroke.
To remove that at an index, we need to do splice. It's splice I0, I think, or I1, so it's the index and then how many to remove. But splice can also be used to replace.
Oh.
But if you don't get what it's replaced with, it just takes one off.
You know what happened? Oh, this sucks. Did I save this code? What's the...
Totally locked up.
Yeah, well, this page is locked up. Hang on a sec. This is the downside of JavaScript in the browser. Developer tools. Okay. Yeah, I don't think I'm going to be able to break out of this. Boy, that would be a really great thing to have. I'm telling you right now, if this fails, I quit.
Can you inspect the page, inspect that element and graph it?
Yeah, that's what I want to do.
You probably can't, 'cause
I can't even right-click the page.
you can't hit the X button up there to like kill the page.
Oh, it will kill.
On the,
Oh, here? Yeah, no. Okay, here's what I'm going to do. It's gone. Always save your code. All right. I have to decide whether to go on now. Ooh, that's smart.
I don't know if it'll work. I'm stuck with a blank page.
It's this one.
Yeah.
Yeah, I think I already got rid of it. It was called Painstaking Wire. Yeah, I don't think it's worth it to like start over from the beginning. But I think that like, I don't know, it feels like the point that I was trying to like get at, like the idea was, is it quick enough to prototype something? And I think the answer there was like, yes, like we were able to like put something on the screen, get it drawing bullets, make it crash, which is always a necessary part of the process. And we were able to do that like fairly quickly. So I'll call it a win instead of trying to do it over. Yeah. Do you hear my computer's actually starting to? Yeah. I think it's probably a better thing to do. So I just like want to ask if anybody has any questions, so that.
There are like so many JavaScript frameworks out there with varying levels of complexity. Is P5 intentionally trying to stay like limited to the sake of simplicity? Because it was really appealing to me actually that it was just a small page of functions, you know, whereas most frameworks would have.
Oh, do you think it's going to be like? Are you wondering whether you think it's going to become kitchen sink or something like that? Like, is it going to?
What is P5's goal there?
Yeah. So P5's goal is to kind of be the processing.org of the web. So the way processing has always grown has been by people adding libraries to it. So there are optional libraries that you load in. Core processing is like a page worth of functions. So that whole aesthetic of you go to the reference page and that's what you see, that's the functions that you have, unless you add like a sound library or something else, that's their core thing. There's one other thing that I think is a real big benefit that I didn't mention during the presentation. But there's a guy on the web that has a video series called The Coding Train, it used to be called. And I think it was called Coding Rainbow or something like that before that. I think it's called Coding Train now. And he just does live streams and stuff with p5.js constantly. And he did like a series on like AI. And he'll do like weird fractal algorithms. He'll just try doing some weird visual effect. And he'll do like a video on it. So like trying to learn things and learning how to do things in just in general in coding and understanding algorithms and things like that, it's a really cool tool for that because he just like kind of live codes the things like 20 times better than I would ever be able to do it. But so there's like lots of really good resources. There's also lots of really good artists that are out there working with this library that are doing good things. So, anybody else? Cool. Thanks.
Does it have functions for audio?
Yes. That's an add-on library in P5. I'm going to try to close this page. But they have an extra library called Sound. I don't know if it's referenced on this page. Yeah, p5.dom and p5.sound. So p5.dom is a way of doing DOM manipulation using p5, and it's just some simple things. But the sound library is actually pretty simple. You can see it's got some pretty sophisticated things. I don't generally add sound to my prototypes, but I think that's actually a downside. I think there's a lot of games that I think if you were looking to prototype something with sound or with rhythm, P5 might actually not be a terrible way to do it. I actually kind of started working on something that I don't have here, but I was working on a quick sequencer and like doing a little drum machine, and doing that in P5 was really easy. I drew my grid, you click on the things just like I was showing you, and it puts the little dots there, and then it's like going across. The timing wasn't as perfect as what you might expect or want, but it was really cool. I was trying to see if I had any other examples. I have a little directory. This is where I keep my my own kind of things. So I had this thing called Snake, probably worth, if I just run it for you, and you can see Python 3-m HTTP .server, I think it is. Yep. So this is just like, I was experimenting with an idea of just moving a snake around by like he keeps moving in the direction that he's moving until you hold down the arrow keys. And then he just kind of floats around on the screen. So things like that are kind of fun to just prototype out. And I do a bunch of things like that. Like I did a little prototype of, there's one called Springs here. Oops. I don't even know if it's working. Oh, these are Boyd's. So this is like a Boyd demo. I guess it's not working, but whatever. But it's easy to even do things like make little user interfaces and things like that. You can see it's kind of failing, but I also have an older version of P5 running here as well. But
So might you use this just to like, instead of like prototyping the whole game, but just like little components of it being like, this is how like this aspect of the game is going to work, or this is
Yeah.
this character's
And I think that's like the key to it. It's like I got to a certain point with Tangam, and I just stopped prototyping there, and I started bringing it over into a real thing once I was ready to make the game. So I think it's useful in that way. But I guess the take-home lessons for me are, don't try to program well. Don't try to make it pretty. Don't try to like use colors and start to focus on bitmaps and things like that. I think sound is good to use if you're trying to get a sense of the feel of it. Like, does sound help? Does sound make a difference? Sometimes games are very much based on sound, and in which case you can do that. Anybody else? Thanks. Appreciate it. I can't believe I crashed my browser.
I did this in 20 minutes on my phone. You seen this game? So
Nice.
I didn't.